morning, gentlemen. How you doing today? This is Mr. Morrow here with you, and we're going to learn about 5-3 today, congruent angles associated with parallel lines. So yesterday we talked about the fact that if two alternate interior angles that are between two lines cut by a transversal, if those two angles are congruent, well, the lines are going to be parallel. If the same side interior angles, okay, have a sum of 180, well, again, those lines between them are going to be parallel. So today we're going to learn the converse of that, all right? Today we're going to talk about parallel lines and the fact that if they are parallel lines and they cut a transversal, you're going to get a lot of equal angles throughout. And that's what we're going to talk about today. So it's basically the converse of yesterday, and on top of that, we've already gone over this, so it should be pretty easy today. Well, gentlemen, the parallel postulate states, through a point not on a line, there is exactly one parallel to the given line. So if I choose a random point anywhere above this line or below the line, but let's focus above the line right now. If I choose any point along this line above it, I can create one exact line that is parallel to the original. So a lot of people argued this throughout history, a lot of mathematicians for centuries. And basically, since we study Euclidean geometry, there's a lot of different types of geometry. Since we teach and study Euclidean geometry, we're going to assume that the parallel postulate holds true. All right, gentlemen, let's see this in action. Well, if the parallel lines are cut by a transversal, each pair of alternate interior angles are congruent. Bam. There's the short form. So in other words, if angle A is congruent to angle B, well then, I'm sorry, if line A is parallel to line B, apologize guys, then angle 1 will be congruent to angle 2. So again, if line A is parallel to line B, angle 1 will be congruent to angle 2. Theorem 38. If two parallel lines are cut by a transversal, then any pair of angles formed are either congruent or supplementary. Now, there's no short form for this, guys, unfortunately. You're going to use it sometimes, but not a lot. What you're going to use this for mostly are non-proofs. You're going to try to figure out angles which are congruent in a figure. So you're going to use this theorem. But in proofs, for the most part, we don't use it. Now, the proof of this may be developed algebraically by letting x be the measure of any one of the angles. So let's follow the steps below. Let's start with x. All right? We know, since this is x, that this guy has to be x. Good. Why? That's right. Vertical angles are congruent. Excellent job. Good job. Okay, next. If this guy's x, we don't know this guy. Now, what do both of these form? Did anyone say linear pair? Because if you did, you're right. You got the bingo. Good job. So that means that these two are supplementary. So this guy would be 180 minus x. All right? Well, guess what? Since I have 180 minus x here, what do you think would go here? That's exactly right. 180 minus x. Now, let's look at the z here. Okay? Look at the z here. If these two guys are parallel, then that means that these two guys right here are alternate interior angles. So, this guy down here would equal, correct, 180 minus x. Now let's do the alternate interior angles reverse. This guy's x, well, this guy's going to be x. Exactly. Good job. Now let's do corresponding. If the underbelly of the f is x, then the other underbelly of the f is x. Or you could have done vertical angles again, but you could use corresponding. And you could use alternate exterior. This guy here, okay, must be equal to this guy here. You could have done it because of supplementary, but you could have also realized that they were congruent because of alternate exterior angles. All right, so hopefully that made sense to you guys. All right, let's move on. Theorem 39. If two parallel lines are cut by a transversal, each pair of alternate exterior angles are congruent. Note, alternate exterior angles are always vertical to alternate interior angles. Let me explain that in a second. All right, so that is the short form, guys. That is the short form. Parallel lines, then alternate exterior angles are congruent. If line A and B are parallel, then that means angle 1 is congruent to angle 2 because of alternate exterior angles. Now, what I was talking about in the second part here in the note, well, alternate interior angles are always vertical to alternate interior angles. Well, yeah, of course. If you do a Z, okay, wouldn't this guy be congruent to this guy? Well, isn't this alternate interior angle across from this guy? Right? So those two would be equal, the alternate interior and the exterior. All right? If you did the Z the other way, same thing. This is an alternate interior, and this is an alternate interior. So isn't this guy congruent to angle 1? And isn't this guy congruent to angle 2? Okay? So exterior angles are always congruent to interior angles because they're vertical. All right? So it's good to know. All right. Okay, guys, let's move on. Now, Theorem 40. If two parallel lines are cut by a transversal, each pair of corresponding angles are congruent. So let's think about that. Parallel lines, corresponding angles are congruent. Well, that means that 1 will be congruent to 2, underbelly to underbelly. 3 will be congruent to 4, top side, top side.
Good morning, Beth. We celebrated in the chapel in 5 minutes. Yes, we celebrated in the chapel in 5 minutes. All students and faculty are cordially invited.
Sorry about that interruption there, guys. There was an announcement for mass. All right, let's continue. So we got corresponding angles here. If line A is parallel to line B, then angle 1 will be congruent to angle 2 because of corresponding, and angle 3 will be congruent to angle 4 because of corresponding. Let's continue. Theorem 41, if two parallel lines are cut by a transversal, each pair of interior angles on the same side of the transversal are supplementary. Basically, this is just the same side. If you have parallel lines, interior same side angles equal 180. So if line A is parallel to line B, angle 1 plus angle 2 will equal 180. Now remember, I know I'm going pretty fast, but I am going to download this onto Edline. And again, this should be all pretty much second nature by now. You should know all of this. We're just defining the theorems already. We had known all of this before, but today we're actually defining the theorems. We're going to learn how to use them. All right, so let's continue. Theorem 42, if two parallel lines are cut by a transversal, each pair of exterior angles on the same side of the transversal are supplementary. So it's same side, but this time exterior same side. So if line A is parallel to line B, that means that angle 1 plus angle 2 will equal 180. Does that make sense, guys? Hope so. All right, let's continue. Theorem 43. If a perpendicular line, okay, is I'm sorry about that. If a line is perpendicular to one of two parallel lines, it is perpendicular to the other. We learned the reverse of this, or the converse of this, yesterday. If line A is perpendicular to this line here, and line A is parallel to line B, well, then that means that line B has to be perpendicular to this line as well. And let's call that actually line C. So again, if line A and B are parallel, and line A is perpendicular to line C, well, then line B will be perpendicular to line C as well. Theorem 44. If two lines are parallel to a third line, they are all parallel to each other. This is called the transitive property of parallel lines. This is nice and easy. So basically, if line A is parallel to line B, and line B is parallel to line C, then that means line A is parallel to line C. It's the transitive property of parallel lines. All right, let us move on. Okay, sample problems. Let's go. Problem number 1. If line C is parallel to line D, I want you to find angle 1. What do you think the first thing you would do is? Come on now. What do you think we would do? Okay, if anyone said, let's set 3x plus 5 equal to 2x plus 5, you are correct. Good job. Let's go ahead and solve for x then. What do we got? Okay, x equals 5. Very good. We're looking for angle 1, right? So that means we got to find what this angle here is, because these guys are vertical angles. So if x is 5, 15 plus 5 is 20, so angle 1 will equal 20. Okay? You can see this all worked out in your book, of course. Okay, next. Number 2. Let's look at the givens here. Let's look at the figure. We're trying to prove that angle E is congruent to angle F. All right? We want to prove that these two guys are congruent. All right, we got a lot of tools in our shed, so let's use them. All right? Okay, first of all, of course, sorry about that, guys. I see what the problem is. Okay, I apologize about that, guys. That was my fault. I had it on infinite cloner. So anyways, okay. Statement number 1. FA is, of course, parallel to DE. And the reason is given. Good. Good. Good job. All right. So what do you think the next thing would be? Okay, we know that FA is parallel to DE. And that doesn't make sense. Okay, sorry about that. Technical difficulty. It's the first time I'm doing this, so apparently I had made a mistake here with my figure. But I went ahead and fixed it. All right, guys. So FA is parallel to DE. All right, so let's see what else. What else will we do now? Correct. Very good. Angle A would then be congruent to angle D. Why? Well, look at the Z. Look at the Z we got. So angle A would be congruent to angle D. Why? Because parallel lines, then alternate interior angles are congruent. All right, next. Correct. FA would be congruent to DE. Why? Because that was given. Okay? Does that make sense, guys? All right, good. Now, number 4. AB would be congruent to CD because, again, it was given. So we've got FA is congruent to DE. Angle A is congruent to angle D. AB is congruent to CD. Now we're almost home here. What do we do now? Anybody? Okay. All right, good. AC would be congruent to BD. Why? The addition property. Well, think about it. This BC is the same for both triangle FAC and triangle EDB. So you're going to use the addition property. You don't have to write that BC is congruent to BC for reflexive. But you are going to use the addition property. Okay. Number 6. Triangle FAC will be congruent to EDB because of side, angle, side. Think about it. You now have this whole thing congruent to each other. So you got FAC is congruent to EDB because of side, angle, side. Okay, so now angle F is congruent to angle E because of CPCTC, and you are done. You are done. Does that make sense, guys? All right, good. Let us continue. Okay, problem 3. Let's try this sucker. All right, this one's going to work this time. I took the cloner off. Okay, for problem 3, line G is parallel to line H. I want to prove that angle 1 is supplementary to angle 2. All right, well, we ain't got much to work with here. We do have that angle G is parallel to angle H. We also know that that's given. Now, if line G is parallel to line H, what do we know here, guys? What do we know? Think about it. Think about it. And before you think about it, let me give you some time. Okay, if you guys noticed, I just messed up again. I had the 3 over here, and that was wrong. The 3 should have been down here, according to the figure in your book. I apologize about that. Okay, so let's move on. If line G is parallel to line H, then we're going to know, of course, that, well, angle 2 is supplementary to angle 3. That's just easy. That's definition of supplementary lines or angles. Now, wouldn't angle 1 be congruent to angle 3? Because of? Who said it? Okay, good. If parallel lines, then alternate exterior angles are congruent. Now think about this, guys. 2 is supplementary to 3. 1 is congruent to 3. So what are we looking for here? Correct. Angle 1 is supplementary to angle 2. Very good. Very good. Good job, guys. Why? Substitution. Very good. Hope everyone sees that and understands that. Okay, let's move on. Now, for problem 4, they give you this figure, okay, and they want you to find angle 1. Now, you can use the parallel postulate to draw M, which is a parallel line to A, all right? Now use the theorem about parallel lines to prove that angle 1 is equal to 120. Well, this is the line we drew through it, okay? We're drawing a line through point C here, which is totally valid. Think about it. If I do my Z, wouldn't this guy be equal to 80 degrees? Yes, indeed. Okay? Why? Because of alternate interior angles. They said these were parallel. These two lines are parallel. So I'm using actually what's called the crook method. It's called the crook method, just like a thief, because you're kind of stealing a line here. You're putting a line through a point. So it's pretty cool. It's called the crook method. Now, if that's parallel to A, if M is parallel to A, M is also parallel to B, and therefore, because of alternate interior angles, this angle here would also be 40 degrees. Okay? So, what would angle 1 be? Well, angle 1 would be the sum of 40 and 80, which would be 120 degrees. And last but not least, guys, we've got the big proof of the day. Okay? Figure ABC with AD parallel to BC, AB congruent to DC, and AB is not parallel to DC. They want you to prove that angle B is congruent to angle C. Now, for this one, it's pretty tough. Okay? It's a long proof, but we can handle it. Now, the thing is that I'm running out of time. So I'm going to go ahead and show you this proof and walk you through it, but I don't really have time to go by one. All right, guys. So let me just go ahead and cut these out here. And all right. So we got figure ABCD with AD parallel to BC. So you know me, I like to label. So that's parallel, and that's parallel. All right? AB is not parallel to DC. That's given as well. So we're going to go ahead and draw DE. Okay? We're going to go ahead and draw DE, which I should have. Okay. My little effect is not working here. Let's try this. There we go. We're going to draw DE, auxiliary lines. Now, if we draw DE, isn't AD and BC, aren't they parallel? Okay, so wouldn't angle DAE, I meant ADE, be congruent to to BEA? I don't know what I'm doing here. I'm sorry. Wait, guys. All right, guys. I'm sorry. My bad. This is all new to me. I apologize. We draw DE being parallel to AB. I'm sorry. That's the parallel postulate. So it wouldn't really be here. It would be more like here. Okay? That's more like what it should look like because it is parallel to AB. So this E should be over here. So I apologize about that, guys. Okay? So DE is parallel to AB. I drew DE because of auxiliary lines, but of course, the parallel postulate allows me to draw DE, okay, to make it parallel to AB. So now, let us continue. Now, let's look at angle DAE and angle BEA. again, I keep drawing DE. I want to draw AE. I apologize, gentlemen. I apologize greatly for this. Okay, my scale here is a little bit off, but remember, let's just work with me here, please, guys. And again, I do sincerely apologize. So, okay, so now we've got DAE, okay, and we've got BEA. So we've got the Z. So alternate interior angles because the parallel lines are equal. Then we have BAE, okay, congruent to DEA. Again, we've got the Z. All right, from here, AE would be congruent to itself because of reflexive. So far we've got AE congruent to itself because of reflexive. DAE congruent to BEA. Okay. We also have BAE congruent to DEA. All right. So now, easy. Triangle AEB is congruent to triangle EAD, angle, side, angle. From there, AB is congruent to DE because of CBCDC. Now from there, AB is congruent to DC, AB congruent to DC because it's given. So therefore, if AB is congruent to DE and AB is congruent to DC, DE is congruent to DC because of transitive property. Then angle DEC would be congruent to angle C if sides and angles. Okay? So again, angle DEC, this guy over here, is congruent to angle C because if sides then angles. We already proved that DE was congruent to DC because of transitive property. So if sides and angles. Okay? Now, I've got that angle B is congruent to angle DEC because of corresponding angles. So let's look at that. Angle B, this guy over here, is congruent to DEC, this guy over here, because of corresponding. Look at the F. So underbelly, congruent to underbelly. So angle B is congruent to DEC because if parallel lines, then corresponding angles are congruent. And last but not least, if DEC is congruent to C and B is congruent to DEC, then angle B must be congruent to angle C. And there you go, guys. I know I stumbled through this a little bit, but thank you for your patience. Have a wonderful day, and God bless you. Bye-bye.